Hello guys, welcome back to a video. Today we will be discussing about the purine salvage pathway. We know that there is degradation of nucleotides in our body. So during that degradative process, there are intermediates formed, such as when GMP is converted to its end product, there is guanine formed in between, somewhere in that pathway. And also when AMP is degraded, adenine is formed at some place. So these adenine and guanine will enter into salvage pathway rather than de novo pathway in certain tissues of a body where de novo pathway does not occur. That is, brain, erythrocytes, neutrophils and eosinophils will undergo salvage pathway rather than de novo pathway. So these intermediates, this guanine and this adenine, will convert back to nucleotides by salvage pathway in these tissues. So this is the salvage pathway. Now let us look on to the salvage of adenine. So this is the adenine molecule which was formed by degradation, and this adenine will convert to AMP by the enzyme adenine phosphoribosyl transferase. So what happens here is PRPP comes and donates its ribosyl group to this adenine and forms AMP here. So this PRP cleaves off its two phosphate groups and joins with this adenine. So if you look here, this is the, if you just forget this structure and just look at this, that is this is the PRPP molecule. So this PRPP comes and leaves its phosphate group, okay, it leaves its phosphate group and joins with its first carbon to this nitrogen of adenine and forms this bond here. This AMP is formed, that is, this much ribosyl group is donated by PRPP to this adenine to form AMP. So this reaction takes place in presence of enzyme adenine phosphoribosyl transferase. So this is the salvage of adenine. Now let us look into the salvage of guanine and hypoxanthine. So guanine, we know what it is, a purine nucleotide. Now hypoxanthine is a derivative of purine nucleotide, which is similar to a purine nucleotide. So it's a derivative. Now first of all we'll look on to the guanine salvage. This is the guanine molecule. It, in presence of HGPRTase or hypoxanthine guanine phosphoribosyl transferase, will convert to GMP by the same reaction which occurred here. That is, PRPP comes and cleaves off its phosphate group as pyrophosphate group, and it just donates its ribosyl group to this guanine and forms GMP. So this is the bond formed here between this carbon 1 and this nitrogen. Okay, so this is the salvage of guanine. Now hypoxanthine. Hypoxanthine also undergoes the same reaction and it converts to IMP or inosine monophosphate. So here this PRPP comes and cleaves its pyrophosphate group and donates its ribose 5-phosphate to hypoxanthine and forms IMP. So this first carbon joins with its nitrogen and forms IMP here. So this is the reaction or salvage of hypoxanthine to IMP. Now let us look on to the salvage of purine nucleosides. That is, these nucleosides which are formed as intermediates will convert to AMP or deoxy AMP to by this enzyme adenosine kinase, and also guanosine or deoxyguanosine, which was formed as intermediate, will convert to GMP or DGMP by guanosine kinase. So here we know that a nucleoside is a molecule which lack phosphate group in its structure. So this adenosine or deoxyadenosine lacks its phosphate group, and when ATP donates its phosphate group to this adenosine or deoxyadenosine, it converts to adenosine monophosphate or DAMP. So AMP or DAMP is formed from adenosine or deoxyadenosine by enzyme adenosine kinase. Similarly, guanosine or deoxyguanosine converts to GMP or DGMP by phosphorylation from GTP, which then converts to GDP after donation of phosphate group to this guanosine or deoxyguanosine. So this is the salvage of purine nucleosides.